Introduction. So, first of all, I thank you for being here. It's a sunny evening, and most of us will probably have a drink and go home. But you're here to talk about consciousness. That's already amazing. So, what I'm going to give you, however, is a perspective, a couple of different narratives that I, from my work in this field, have sort of gathered, about thinking about what I'm doing, and hopefully, in the course of telling you about it, I'm going to explain to you what do I mean by mohawk. What does that even mean? So, I'm starting first, so I should really start from the very beginning. This perspective that the ancient Greeks had on the nature of consciousness, the nature of what it is to be human, it goes way back. So Hippocrates, the father of medicine, sort of seems to have chanced upon this device, sort of almost clear evidence of what it is that men ought to know. Men ought to know, he says, that from the brain and from the brain only arise our pleasures, our joys, our laughters and jests, as well as our sorrows, our pains, our griefs, and tears. It's really well put. And really, I mean, if this had been said in that period of time, what more is there to say? However, what's really bothered us since then is mechanism. So the Greeks wondered too, how is it that the brain does all these things? And we wonder even today. And their take on it was to think about the notion of humors. This was the day and age of hydraulics, Archimedes and all that. So it was all about fluid flow. The Greeks thought, well, what really makes us us? What gives us personality? What gives us traits that make us specific and individual and unique? Are these sorts of different humors? So the ratio of these different fluids flowing through your body, they said, makes you a certain kind of person. So you can be more melancholic if you've got a particular kind of fluid called the melancholic fluid, and that pattern of fluid is what defines you. The rest of what the brain does, the tissue around it, was something of a mystery to them. And really, this idea is surprisingly robust, even though not necessarily in Western cultures. So I come from India, and in India, the notion of humorism is the idea that there are these humors, these fluids that flow through your body that control your health, control your consciousness, is very, very alive and well. However, really, only in this sort of Renaissance do we see a change in this idea. Remarkably, for 1,000 years, more than that, it was a very sort of robust idea that survived in medical literature. So only in the 1700s do we start thinking about the fact that actually the narrative of how our brains and our bodies embody us and create consciousness starts to evolve towards electricity. That's a radical concept in those times. And Galvani, who used to do these crazy experiments where he used to sort of zap frogs, zap cadavers, and show that actually you could make them come alive through electricity. That was electrifying at the time, when you sort of make women faint in the audience using sort of really clever experiments. Going forward in the 1800s is when this narrative explored further. Actually, it's not just animals who are controlled by electricity, it's us too. So these researchers, Richard Caton, who's a bit less well known, and in particular Hans Berger, who's sort of famous for having created a first signal of electrical activity from his own sun, recorded just by placing an electrode on his son's head. So this is something I do too. And this picture made him famous. And this is something he sort of showed, that our brains, our bodies are also driven by electricity. And at the time, it was remarkable that we could actually measure anything sensible. And this is something I do today too, using the same sort of technology called EEG, which is essentially a short electroencephalogram. It's a way to measure the electrical activity that your brain is producing all the time. And it turns out that what you can measure has a pattern to it. It's not all gibberish. And if you do that, if you do it with lots of senses all over the head, then if I asked you to right now, in a sort of alert, awake state, sit there for 10 minutes and I recorded the activity in your brain and looked at what bits of brain are talking to what other bits of brain in the patterns of those electrical activities, I can draw a map like this. This is just a healthy adult just sitting there for 10 minutes. What you essentially see is that there are a set of areas in the brain which, as a neuroscientist, I can pin down, and I can say, well, this pattern of connections, so spans the front and the back, seems to go along with consciousness. And I call it a mohawk. It's an easy way to sort of capture this idea, which actually somebody else on a Reddit forum gave me the idea. And what it suggests is that there are brain areas that seem to contribute to this state of being conscious, to the state of having a narrative that we take for granted. Because there is a lot of research in neuroscience that we can really sort of fall back on as this develops. Because it turns out that this pattern I showed you, that mohawk, really comes from, if you look inside the brain using functional imaging, obviously, I'm going to be the guy who's going to talk a lot about data. And so if you look at functional imaging data, it turns out when you're thinking about yourself, so when you're thinking about what you're going to have for dinner, who you're going to go out with late in the evening, what you did yesterday, where your next holiday is going to be, etc., etc., there are a key set of brain areas that form a network that sort of goes along with having that narrative in your head, that sort of trail of thought, as it were. And there are other times, like, for example, now when you're listening to my voice, you're looking at me, and a different set of brain areas there are coming together to create the sensory awareness of my voice. And what's happening, it turns out, is your brain's constantly switching between these networks. You take in information, you make it relevant to yourself. You create narrative, and then you go back to listening to more stuff. So you do this back and forth all the time under the hood. This is happening as your consciousness progresses through your day. And that's interesting because that progression is something I study. For example, what happens when you go from full conscious wakefulness now to sort of light sleep after lunch and deep sleep tonight, hopefully, and how that changes. And what turns out quite nicely to be the case is that pattern of connections between those frontal and parietal areas, those front and back connections, that mohawk completely disappears when you fall asleep. That's good. So it gives me a good handle on the fact that yes, there's something in those connections that's changing, something is switching off when you really are asleep, without any dream, of course. So when you're dreaming, that's an entirely different matter. Another example, I'm going to show you a movie now, how this changes. We can actually track this in real time, which is, for me, a clear demonstration of the fact that there is something useful here. But this is a movie where somebody is being given an anesthetic, a drug, to make them fall asleep. It's the same one you'd get if you've ever been to a hospital and had general anesthesia. It's a very common drug, nothing special about it. And what you see is, over time, there's a lot of change, but there is a kind of a mohawk-like pattern that links primarily brain areas in the front and the back. But as the drug starts taking effect, it starts to weaken. And as it weakens, you'll see that pattern drop all of a sudden, about right there. And that mohawk disappears, and you get a frontal sort of pattern of connectivity that is sort of paradoxical. At this point, this person is fully unconscious. They're not responsive. There's no way you can wake them unless the drug is eventually flushed out. So the lack of consciousness due to anesthesia also goes along with the loss of that mohawk. So when you don't have consciousness, you don't have the mohawk. And when the drug is eventually flushed out, in about a few more minutes, a few more seconds really, because the whole thing is 2 hours of data scrunched into a minute of video. As that person then recovers consciousness, that mohawk comes back. So what's interesting is you can track it over time. You can make a movie of how, when you lose narrative, you lose a certain pattern of brain activity. It doesn't mean that brain activity is the only cause of that narrative. Obviously, it's only a correlation. But the fact that we can measure a correlation is an advance, and certainly the ancient Greeks would think so. So this brings me to a crucial second element of narrative that actually, for me, is the main thing that keeps me up at night, keeps me working in this field. What happens when you've got patients who are so-called vegetative patients? So I work in a field where I work with doctors to try and assess consciousness in such patients, because they represent a unique disjunction, because they have a certain level of consciousness. They're not in a coma, something I need to clarify, because a comatose state is the lack of a level of consciousness. Patients in a comatose state are not awake, neither do they have any contacts, any thoughts. Patients who are in a vegetative state have progressed beyond that. They're awake, they'll have their eyes open, they'll seem to look around the room, but is there a narrative in there? Is there a person in there? Is anybody home? This is a question that's very difficult to answer because they can't tell you, even if they do. This is a challenge for clinicians, this is a challenge for us as a society. How do we deal with this? Because it's becoming more and more common as critical care medicine gets better. So it's a real world problem. And to illustrate the obviousness of the problem, here's some data again. So as I said already, that's a mohawk of a healthy adult. It's like you, with strong connections between the areas that seem to mediate this consciousness, the consciousness of one's own narrative, consciousness of the world outside. You compare that to a patient who's in a vegetative state. It's fairly easy to see the massive loss of brain activity, the massive loss of brain function, obviously due to the injury that has put this person in a vegetative state and has led to the loss of those networks. Now, comparing that to what happens when you lose consciousness due to sleep, due to anesthesia, I hope you'll see that there's clearly a pattern that one can extract, which links consciousness to certain patterns of brain activity. However, just to make things really complicated, that's another vegetative patient. So this leads us to obviously, we have to take a second look. You have to think about what that means. Because I don't think the answers are something that are easily forthcoming. But here's a patient who behaviorally, from their bedside manner in the hospital, had nothing different from that patient. And we have evidence, behavioral evidence to that effect. So we measured their behavior in quantitative ways, and we said, well, these patients both appear to be vegetative. And then you measure this in the brain activity. Now, what's going on? It turns out this patient had hidden awareness that wasn't evident in their behavior. What do I mean by that? It turns out that actually there are ways in which you can measure the presence of consciousness that sort of suddenly does not rely on behavior. How do I know you're conscious? Some philosophers would say, of course, you cannot know about anybody else's consciousness. You might all be zombies as far as I'm concerned. I am only aware of my own consciousness. I can only assume through a consensual view that you are conscious too. Now, an alternative approach was proposed by some scientists right here at Cambridge who suggested, well, why don't we get these patients to imagine playing tennis? It's a bit of a strange thing to do, but the reason they did that was when you imagine playing tennis, and I put you in an fMRI scanner while you do that, a particular bit of brain lights up. The bit of brain that basically drives the motor imagination, the imagination of actually hitting the ball and scoring an ace. It turns out a patient who was in a vegetative state, there was no evidence of any behavior at the bedside, was able to do this. So how is it possible? At the time, everybody was gobsmacked, so were the scientists. Since then, it's been replicated that 10 to 20% of patients who are in a seemingly vegetative state can have hidden awareness, for example, measured using such a task, such a way to basically lead off this presence of intent in the absence of behavior. And it turns out that the one patient I showed you who had this amazing pattern of brain network activity, the connections in his brain were strong, robust, indistinguishable from that of yours or any other healthy adult, also was able to imagine playing tennis. And we put him in the fMRI scanner and we asked him to do that. He complied with that instruction. And all that while we're collecting this data, this patient, from a behavioral perspective, was in a vegetative/comatose state, because this is his clinical discharge report. Because it says, his clinician agrees that he was in a coma throughout his stay at the hospital where I tested him, and when he left, he was still in a coma. I'm not saying the clinician's wrong, but clearly there's something going on there that's not evident in one's behavior. And this is a question that for us asks a direct, relevant element of what narrative actually is and how much can we infer about narrative with these sorts of data. What can we say about what narrative he had? He played tennis, doesn't mean he had a full internal memory, a full rich consciousness, but what does it look like? Because it asks us to reevaluate what consciousness can be like. So that sort of really brings me towards the end of my talk, and hopefully I'm well on time. But there are a couple of key questions that sort of I want to leave you with, because it's not about answers, but questions really. The first question is, how can I tell you're conscious? And I think, hopefully I've shown you, there are tools with which we can use neuroscience, we can use understanding from psychology to answer some of that. I can probably tell with a certain well above chance level of accuracy the answer to that question if I had a bit of data from your brain. So I can sort of supplant behavior as far as that question goes. But what else can I say from your brain? What are you conscious of? Now that's interesting. So in other words, what's your narrative like right now? I can probably guess, if you're listening to me, your narrative has some relevance to what I've said, but more generally, can I track narrative that your brain is sort of creating for you from moment to moment? That's harder, that's much harder, but there have been some researchers who've said, yeah, I can sort of boil down narrative to a couple of networks in the brain. So that's interesting. But the hardest one, I think the most fascinating one for us in this context is, what's it like to be you? So what's first person experience like? How does that uniqueness of it come about if we've all got roughly the same kind of brain? How is it that that's so unique and so specific that it's central and core to our existence? I think that's a much harder question. I don't think neuroscience has any immediate answers to, but really I think it'll be amazing to hear from the other speakers what they have to say about the matter. Thank you.
Thank you so much. Don't stand in front of the lights, you won't be blinded. Do we have any questions for Srivas? That's the mic there. Thank you so much.
Has anyone done similar EEGs on animals when they're falling asleep? Have you seen similar patterns there?
Really interesting question. Absolutely, that's right. And it has been done, and you do see, obviously depends on the animal. So birds are very interesting. Birds don't sleep like we do, unsurprisingly. So macaques and chimpanzees, however, there are very similar patterns, absolutely.
So would you take that to say that they've got some sort of narrative going on when they're conscious?
Great question. No, you're not going to obviously trap me with that one, of course. But I'm going to say I don't know. I'm going to ask the monkey, like time will let you know what it says. But basically, the question of what that network represents, what the pattern of activity represents, right now I can only say it is a level of consciousness. It's a level of information integration in the brain that seems to go along with being able to act in an intelligent manner, being able to be that individual from an outside perspective. What it means from the inside, I mean, that's anybody's guess. And really, we don't have the data to say anything specific about, certainly about non-human primates, but we can't ask the questions.
Thank you so much. Any other questions?
Yeah. You might get one.
I'm Susan Graves. Sorry I haven't prepared the question properly.
Fine.
But thanks for such an interesting talk. You know when you give the
EEG, yes.
to the patient, whether it be human or animal, do you think that space matters? So that in a small space you might get different results, and in a larger space it would be different again.
Do you mean physical space, the space in which I'm measuring? Right. So that's interesting. Without doubt, those patterns of activations, like in the movie I showed you, are changing all the time. There are lots of visual, sensory stimuli that affect the pattern of activation. So without doubt, it's going to have an impact. Exactly what the impact is going to be, I don't think we have a specific handle on that yet.
Thank you.
I'm very interested in the posterior cingulate cortex.
Oh wow, this is easy.
And I understand that there's an awful lot of evidence that it's involved in self-awareness.
Right, yes.
And if there's no activity, a person is unlikely to come out of a coma state. But if they see some, are you working on that at all?
Absolutely. So those networks I showed you, the fMRI, sort of what's going on under the hood, the posterior cingulate cortex, which is sort of, for perhaps uninitiated, somewhere in the middle of the brain, but at the back. There's a posterior and there's an anterior cingulate, and they both form a part of what is known as the default mode network. A set of brain areas that seem to be active when you have narrative going on. The presence of activation in that network is not just one area that seems to matter, but in the network as a whole, does seem to have a positive predictive value for recovery from coma. Yes, that's true.
Thank you. I'm afraid we're going to have to move on now, so please a round of applause for Srivas Chennu.